Good morning, all of you. In this class, we have discussed the multiplexer tree. So, what is exactly the multiplexer tree and why it is called as multiplexer tree? Basically, that tree itself name suggests that function or that branches. Yes. So, we are already discussed in our previous video that 8 is to 1 mux. 8 is to 1 mux. Simply by using this functional block diagram, we can easily draw or find out the value of this by using 8 is to 1 mux, that is output y, and the functional truth table we are having with for this 8 is to 1 mux, that is S2, S1, S0 as the your select lines, and the by depending upon the select line we are getting the output as y, that is D0, D1, D2, D3, D4, D5, D6, D7 as a select line though selected. So here as 8 is to 1, that is the traditional mux we are having with. But if they ask that is 8 is to 1 mux, 8 is to 1 mux using 4 is to 1 and 2 is to 1 mux. By using 4 is to 1 and 2 is to 1 mux. So here by using 4 is to 1 and 1 2 is to 1 mux, we can easily find or we can easily draw that functional block diagram for 8 is to 1 mux. See now, here by simply drawing 4 is to 1 mux. So we are having with this 4 is to 1 mux, basically that 4 is to 1 mux having as 4 input. For that, if you convert this 8 is to 1, so 4 input for D0, D1, D2, D3, that is first 4 input, and the one of the output, that is 1. So we can say that this is what your y0. Yes. Next, for that second, that D4, D5, D6 and D7, that is another 4 input, and the other output, that is what we can say that y1. Okay, that is what the 4 is to 1 multiplexer, and here that one of the input to that particular 2 is to 1 multiplexer from 4 is to 1, another 4 is to 1 multiplexer and another 4 is to 1 multiplexer. That output of this first 4 is to 1 multiplexer, that is y0. So here is the input to that 2 is to 1 multiplexer, that is y0, and here that output from that another multiplexer, that 4 is to 1, that is y1, is input to that y1 to 2 is to 1 multiplexer. Here we get the output y. So how we get particular output? See here, as function table says that if 0 0 0, how we can get the value here? As first 0 0 0 as select line 0 0 0, so the D0 is to be selected, 0 0 0, so D0 is selected, and here the output y is equals to D0 we are getting. Yes. As the same thing as 0 0 and 0, but in this case if we convert from 8 is to 1 to 4 is to 1 and 2 is to 1, so we are having with the 2 select line, as if you see here that connection point of view, that S0 and S1, H0 and S1 are the select line. These select line are common for 4 is to 1, for first 4 is to 1 multiplexer and another 4 is to 1 multiplexer. You can draw the separate also. You can draw it separate also, that is S1 and S0 for first and S1 and S0 for second also. This is one of the way to draw the multiplexer, 4 is to 1 multiplexer, that is talking about the multiplexer tree. And here we can draw the logic 0 also, that is what some of the time we can say that this is what your logic 0, and for this multiplexer again this is what your logic 0, as we can call it as a ground, or sometimes it is what logic 0 in the digital. So here as S0 and S1, basically we people know that 8 is to 1 multiplexer having with the 3 select line. This is what your 3 select line, and in this case here for 4 is to 1 multiplexer we are having with the 2 select line, and here also 4 is to 1, that separate 2 select line. Yes. So what happened basically for this S1 S0, as S1 and S0, that is for 4 is to 1 multiplexer, that functional table for this 4 is to 1 say that if the value of this is 0 0, that select line is 0 0, then D0 is to be selected. Then D0 is selected. Here means the first input is selected. So suppose the value for this is what 0 0 here, that enable, we can say that the first is what if we say that, okay. So if you draw for this separately, so this is what your S1 and S0, this is what for first S1 and S0, and this is the second as S0 and S1. Okay, separately we can draw it separately. So here first the value of is 0 0, so in this case it's 0 0, so D0 is selected and the value of Y0 is D0. Okay, the value of Y0 is D0 in this case, and here if the value of this is first again that 0 0, again we can say that the value is 0 0, then D4 is selected. So value of Y1 is D4, because again the 0 0, so value is 0 0, S1 and S0 agar ye 0 0, this one is what your 0 0, then D4 is what the value of that 0 0 is D4. Now here that Y1 is equals to D4, that Y1 is equals to D4, and we are having with that Y0 is equals to D0 and Y1 is equals to your D4. Okay, for 2:1 multiplexer. Now again check the truth table of or the functional table of your 2:1 multiplexer. As 2:1 multiplexer says that if the value of the select line is 0, then D0 is means first output or the select line is or the input is data input is selected, and if the one is selected, that second one is selected. Now in this case, if you see here that first one is what D0. So in this case, if the value is 0, because we are talking about the 0, no, so it is what the first, as the value of this is S0 and S1, already we have selected that 0 0, and the second term is S2 is what 0, so that's why we have selected S2 is equals to 0, and if suppose we have selected S2 is equals to 0, so D0 is selected, and finally we are having with the value is what D0, as our 8:1 multiplexer is also Y is equals to D0, and here by using 4:1 mux and 2:1 mux, or Y is equals to also D0. So this is nothing but your multiplexer tree for 8:1 mux using 4:1 and 2:1 mux. Thank you.